Let me introduce you to the Accurate Mass Quant Isotopic Pattern Match workflow. And the context here is we have several workflows in Quant, including its cousin, which is the Quant Spectral Match workflow. And I'm going to be specific here about the pattern match workflow. So what that means is we're going to go through the regular quantitation that we're very familiar with, but in addition to that, in an integrated manner, we're going to provide you with pattern match information. And what that means is we're going to take the actual accurate mass spectra that you've acquired and match that up against an exact mass predicted pattern that's come from the formula to create an isotopic pattern. And with those two spectra, comparing them, we're going to come out with three scores: the accuracy, abundance, and spacing. And those scores are going to be totaled up to a total mass match score. And that score will give you a confidence in your quantitation. You'll end up with the final concentration and confirmational evidence that that pattern match has given you a score that you're satisfied with, producing, as I said, confidence in quantitation. Let's look at the terminology involved here. First, the term isotopic pattern. Now that would be the predicted ion distribution, and you're going to need the formula because you're going to use the formula to synthesize that from the naturally occurring isotopic ratios. The reference library that we're going to create is going to contain those isotopic patterns, and we'll call that a pattern reference library. That contains the species that are generated from these formulas, and in electrospray they're typically denoted something like M plus H, M plus sodium, or M plus potassium. That's a typical variation of that. And the last term is the mass match score, which is the total score that represents a correlation between the accurate spectra that you've acquired for that species and the synthesized or the exact predicted ions masses that you've predicted for that set of species. And the score that's produced here is an aggregate score of the best pattern match of any of these species which has been generated, and that's reported as three separate scores: accuracy, abundance, and spacing, which are totaled up by a weighting to give you the total mass match score. This diagram conveys the meaning behind the accurate mass metric. So we have accuracy, of course, exact mass versus the actual mass that you've acquired. We've got abundance, which is the intensity of these ions relative to each other. And then last we have the spacing between the ions, which you would expect to match up quite well if the compounds were the same in an accurate mass machine. Walk through the steps. So here I am in the Quant method editor, and I have the capability of generating a reference pattern library, assuming that I have the formula, and I get a choice of which adducts or species to generate. These are the kinds of adducts that are typically created in electrospray. And what I'll end up with is a reference library. So let's take a look at that in the Quant library method editor, with, for each compounds, the patterns stored as spectra. So here's M plus H, M plus sodium, and N plus potassium. And an advantage here is that I can, let's say, remove one of the adducts if I don't think that it's going to occur, or I can actually manually edit the ions myself. And if you think about it, if I'm going to go into a production quant confirmation workflow, it would be worth the effort to curate this pattern library. Let's take a look at the presentation in batch at a glance. Here I've got the mass match score metrics, and in the spectrum I see
the predicted isotopic ratio versus the actual. And the beauty of the mass match score is that it's like looking at a forest. I don't have to see the entire forest. I can look for the species that I'm interested in and measure the occurrence of that species to build confidence that I'm looking at the right compound. All right, here I am in the Accurate Mass Quant method editor, and I've got formulas for my compounds, and I'm going to use the method menu and set up a reference pattern library. So I get a choice of which species I want to generate. I'm going to pick N plus H, N plus sodium, and N plus potassium because this is an LC-TOF ionization, an electrospray. And it will go into the library editor and create those compounds as I showed you in the slides. So now I've got that. If you want to look at the globals, you'll see that that library is referenced here. So now I'm going to go back to Analyze. I see my mass match scores, and if I zoom in on my spectra, I can see the presentation for each of these mass scores, and I can zoom in with the fit to peak, and it will show me the correspondence between the expected isotopic pattern and the pattern that I see. Real confirmation evidence.